All right, today we're doing something a little different. We're going to go full-on forensic investigator and crack open the case of a notorious killer in the poultry world, Salmonella. We're about to uncover just how this infection works from the inside out, piece by devastating piece.
So this really is the central mystery, isn't it? How can something so small you can't even see it cause such widespread, visible, and just awful damage? Well, to solve this, we've got to start with the evidence.
You know, any good investigation begins by examining the scene. And let me tell you, the scene here is grim. In the eyes, we find these hard, white discs of material. Then you look at the cecum, that's part of the large intestine, and it's just filled with these white, cheesy casts from severe inflammation. The liver, it's swollen, it's discolored, and it's literally dotted with dead tissue. Even the air sacs are thickened up with these same opaque, cheese-like deposits. So now that we've seen the damage, it's time to identify our prime suspect.
Okay, so we've seen what happened. Now let's figure out who's responsible. We are about to build a profile of our prime suspect.
And here it is. Meet our culprit, Salmonella. It's a gram-negative, rod-shaped bacterium. But that last part of its profile, that's the really important bit. The part that makes it so dangerous is that it's a facultative intracellular pathogen. Now that's a mouthful, but trust me, it is the absolute key to understanding its whole method of operation.
Let's break down this profile. Each of these features is part of its criminal toolkit. Being gram-negative, that means its cell wall has a hidden weapon, and we're definitely coming back to that. Rod-shaped, well, that's just its physical description. But being a facultative intracellular pathogen, oh, that's its genius move. It means Salmonella can actually live and multiply inside the host's own cells. It's like a spy hiding in plain sight, completely shielded from the immune system.
Okay, so we've got our suspect. Now we can start to piece together its playbook. How exactly does Salmonella carry out its attack?
The plan is deceptively simple but brutally effective. It all starts with ingestion, getting eaten. But it doesn't just hang out in the gut. Oh no, it invades. It literally punches through the intestinal wall. From there, it gets into the bloodstream and causes a systemic infection. This can be a really fast, acute septicemia or a slower, more chronic bacteremia. But that final step, that's the most devastating part. As the bacteria start to die off, they release that hidden weapon we talked about.
And here is the plot twist. The living bacteria? Yeah, they're a problem. But the real systemic damage, the fever, the inflammation, the hemorrhaging, that comes from a poison they release only when they die. It's called an endotoxin.
Now, this is so important to understand. This endotoxin, its technical name is lipopolysaccharide, or LPS. It's part of the bacterium's own cell wall. So when the bacterium dies and breaks apart, this toxin gets released. But here's the really insidious part. The toxin itself doesn't cause the damage directly. Instead, it tricks the host's own immune cells into releasing this massive flood of inflammatory chemicals. The body, in its desperate attempt to fight the infection, ends up attacking itself, and that's what causes all that systemic damage we saw at the crime scene.
Okay, so now we're zooming in. We're going from what we can see with the naked eye down to the microscope. This is where we find the forensic fingerprints that prove, without a doubt, that Salmonella was here. And the #1 spot to look for these microscopic clues is the liver. The kind of damage you see here is highly specific to a Salmonella infection. Now, the quote says it's not pathognomonic, which is a fancy way of saying it's not a 100% confirmation all by itself, but it is the single best place to find our suspect's signature.
So what exactly is this signature? Well, it's something called a paratyphoid nodule. And this might sound like it's a colony of bacteria, but it's not. It's actually a tiny cluster of the host's own immune cells, these macrophages and histiocytes that have all gathered together to try and fight the invasion.
This really shows you the battle that's happening at the cellular level. The immune system's goal is to surround and contain the Salmonella. And the result of that tiny skirmish is the formation of these nodules. They are, quite literally, the microscopic fingerprint left behind at the scene, proving our culprit was there. And this damage isn't just in the liver. The fingerprints are all over the body. Under the microscope in the intestines, we find massive inflammation, bleeding, and cell death. And with certain strains of Salmonella, you can even find lesions in the central nervous system. This invasion is truly deeply systemic.
So with all the evidence gathered, from the major organs right down to the individual cells, it is time for the final verdict.
So let's recap the case against Salmonella. First, this infection is a multi-stage invasion. Second, all that visible organ damage we saw is a direct result of that invasion process. Third, the bacteria's secret weapon, that endotoxin, turns the body's own immune system against itself. And finally, those microscopic clues, those paratyphoid nodules, are the definitive fingerprints that absolutely close the case.
And all of this leads to one final critical thought. We've figured out how Salmonella causes all this devastation, but it leaves us with a much bigger, much tougher question. How in the world do you fight an enemy that weaponizes the very system designed to protect you? And that right there remains one of the greatest challenges in medicine and immunology today.